In this video, I'll do a few simple total demos. I'll do 3 from our textbook and then some from our sample demos file. Let's start with an example from our textbook, and we're going to find the average salary of a booking agent. Now this one should be fairly simple. We're going to select the average salary, and we'll give it an alias. How about as average agent salary? And it's coming from the agent table. So let's check that out. And we get $24,850. Nice little warm-up exercise there. Let's go on to something a little more complicated. We're going to show the engagement numbers for all engagements that have a contract price greater than or equal to the overall average contract price. Hopefully you recognize a subquery in that question. So I'm going to start by finding the average contract price. So here I'm going to select average contract price. I'm not going to give it an alias because I'm going to use it in a subquery. From engagements. Let's see how we do here. And I have 1266.21. I'm just going to copy that out of here and put it here as just a sort of a reminder. Now the next part I'm going to do is I'm going to select engagement number from engagements where the contract price is greater than or equal to. Greater than, equal to. Now here comes my subquery. So it's greater than or equal to the average of all contract prices. And let's give this a try. I show 43 rows. I've already double checked that, and 43 is correct. Go ahead. So let's see if we can dress this up a little bit. This doesn't tell me much. Engagement number, I think I'd like to have a little more information. So I'm going to grab this again, and we're going to do engagement number and engagement as E, because I'm going to do an inner join on this. I'm going to do E dot engagement number, comma, let's see, how about customer? Let's get some information about our customers here. And I want the customer last name and customer first name as, how about full name here? And I have to put the apostrophes around it, the single quotes, because I have a space in it. As full name, from engagements as E, and we'll do an inner join. Customers as C, and we'll run it and see what happens here. I haven't double checked it. That looks pretty good. Now we have the engagement number and actually the name of the customer who's associated with that engagement. So it gives us a little more information. It also gives us an opportunity to practice some of the skills that we learned in the earlier chapters by doing a concatenation and an inner join. and a subquery. So how about how many of our entertainers are based in Bellevue? Let's take a look at that. We'll do a count. So we'll count, and we're going to count all. As, let's give it an alias. I'm not going to use spaces in it this time, so I don't need the single quotes of entertainers. And that's going to come from our entertainers table. Where entertainer city is equal to Bellevue. And it would help if I have a select in there. That looks a little better. We have 3 entertainers from Bellevue. Let's do a little more work with this. Practice some of our skills. Let's try, I'm just going to copy this. Select, and we'll do the number of entertainers based in Bellevue is so now I'm going to have 2 columns. One is the number of entertainers and the second is the count. And let's give this a try, see how it turns out. It doesn't give me a column name, but now I have something that is a little more identifiable. The number of entertainers based in Bellevue is 3. Let's try this one more time and change it around again a little bit and remind ourselves of some of our earlier work. And I'm going to take this and I'm going to select the number of entertainers based in Bellevue is, and I'm going to do a concatenation with it this time. And so I'm going to take out the comma and put a plus in here. And if I try to run it, I'm going to get an error message. I'm trying to add text to a number value. So what I'm going to do with this is I'll do a cast, and I'm going to cast as character. And I'll bring this to the next line so we can see it and give this one a try. So now I've just basically put the whole string in one column by doing a concatenation, and I also used a cast to convert my count to character and concatenate it to my text string. So here we took a look at average, a little more average work with average. Average is a subquery. We did a concatenation, an inner join, and a subquery. Here we did a count. Our second one, we created 2 columns. And on our third one, we created one column by concatenating the text string to the count of the entertainers and cast the count as a character. So there was a simple review of some of the skills we've already used so far in this class. Now we're going to take a look at our demo file on aggregating data, and we're going to use the AdventureWorks database, and we're going to go through and find out how many internet customers does AdventureWorks have. We use the count all, and I select it. I come up with 18,484. We could test this by doing a select And let's see what field we should select here. How about a primary key field in the customer? Because this field should have a value in it. And we get the same number, 18,484. So how many different products does AdventureWorks have? Here we're going to use the distinct keyword inside the count function. So we have 504 distinct products. Now what we're doing is we're counting on the product alternate key, because what happens in the data warehouse is that as products change over time, the product alternate key is the identifier for that product. However, when the product price increases and the product is added to the table again, it gets a new product key, but the product alternate key remains the same. That's why we'll see a difference between this and this. So we have the product dimension records are changing over time. They will reflect a price increase or a price decrease for that matter. So what is the dollar value of all internet sales? We're going to use a sum, we're going to use an alias, and that is a number way too big for me to say. So let's double check then to see if our data is consistent. So I'm going to copy this, and I'm going to put it up here so I can remember it, and if I throw in a few commas I might even be able to say it. So let's check this one to see how it works. And we end up with the same thing. So our data is consistent. So let's try this and select both sums in the same select, which showing we can put multiple aggregate functions within the same select statement. And we have two numbers that match. Now what is the dollar value of the internet sales for 2006? What we're doing here is we're adding a where clause. You saw this in the earlier example I did from the textbook. And so I just want to know the sum of the total sales from the fact internet sales table for the order year 2006. And I'll plug it in back here so that I can keep that value. Now moving on, what is the average yearly income for an AdventureWorks customer? So we're going to find the average yearly income. If the yearly income value is null, the average aggregate function is going to ignore that value. And here we have 57,000. So I'm going to plug that number up in here so I can save it for later. Helps me to read them if I throw commas in. Now what we want to do is we want to list all customers who have a yearly income that is above the average for all customers. When we see that, it should signal subquery to you. There's our subquery. We're going to select the average yearly income for all customers. This number should match this number. And it does. So now I'm going to go ahead and run the whole thing. So what we've done is we've chosen the customer key, customer last name, customer first name, the yearly income, where the income is larger than the average yearly income. And the average yearly income is just over 57,000. So I'm going to change this around to put the smallest amount at the top to compare it to my value here, 60,000. And I think that if we look at our data, we'll see that the yearly income values are all nice round numbers. So this looks correct. Now we've got one that's a little more complicated here. We want to know the lowest price for which a bike has sold. So we need to get the unit price from the fact internet sales table, but in order to know that it's a bike, we have to interjoin all the way through to the product category table, or at least to the product subcategory table, because by now you probably know that the bike subcategories, I believe, are 1, 2, and 3, so we could get there without going all the way to the product category table. So we're taking the minimum unit price from the fact internet sales table as F. We're going to join it to the product table. The product table allows us to join to the product subcategory table, and the product subcategory table then allows us to join to the product category table, which allows us to pull bikes from the English product category name. Now in your homework, I often see an error right here. What's happening is that I'll see subcategory on one side and category on the other side. So be sure and check that if you're taking the product subcategory from the subcategory table, you're linking it to the common field, the matching field in the product table. So make sure that these match. Let's double check our results. Let's run this and see what we come up with. I missed something. And we'll run it again. There we go. Last time I left out the final single quote. And we have 539, or yes, 539.99. Let's put it here so we can refer back to it. And let's double check. What we've done here is we're finding bikes and we're sorting them in ascending order so that the smallest one will be at the top. And this number does match that number. So we've been able to check our work. Next thing we're going to look at is what is the lowest price for which a bike is sold and what is the highest price for which a bike is sold. We've already done most of this. We did it up here where we found bikes. So now we're just going to put the minimum unit price as low price and the maximum unit price as high price into our select statement, and then basically we can copy and paste the join all the way down. Now we have already confirmed that this is the low price. Now let's confirm that this is the highest price. And I can do that by coming back up here, this one, and I can put a different sort on this, and we'll try it again. And I'm going to pull this number out and put it here so I can refer back to it. And I'm going to run this again. And this number matches my proof. So what we've reviewed here is the count all, count using the distinct keyword with a count, sum, adding an alias, double checking to see that our data is consistent and proofing our work. We've used and finding sum with a where clause. We found the average yearly income for an AdventureWorks customer. We tucked that into a query as a subquery to compare the average yearly income with the results of that subquery. We added an order by. In the next one we looked at min, and we interjoined through to find the bikes category. We double checked our result and we sorted it a couple ways so we could use it in a couple of different proofs. Then we found the min and the max. We put two aggregate queries in one select statement, and again we proofed this one by coming up here and doing the sort in another direction. So we've reviewed inner joins, subqueries, and we've introduced some aggregate functions.